Jeff Brandt, who will talk about IoT devices. So, Jeff, are you online?
I am. Hey, Frank.
Howdy. All right.
Hey.
Floor's all yours.
Thank you. 1 second. Let me share my screen. And thank you, Frank, for putting this together and all our presenters. It's been a wonderful and enlightening experience so far. So yeah, my name is Jeff Brandt. I'm a technologist and solutions architect with the Langley OCIO. I've actually been involved with AR VR for a while. I remember our first XR TIM, I think in 2017. It was a pretty cool experience. I hope one day we can get back to the in-person meetings. But one of the other technologies I've been involved with is IoT, or Internet of Things. And I find oftentimes the intersection of two different technologies gives a lot of new opportunities. The case in point, Ryan's example just now with the generative design and bringing that into VR, and it kind of opens up a whole new world of potential. So for some background, just to introduce Internet of Things for those of you who may not be super familiar with the concept, it could really be summarized by systems and devices that are connected by the internet. So it can include devices such as your smart home devices and thermostats and that sort of thing, your voice assistants. It could be, you could even consider a mobile phone as part of an IoT architecture when used that way. So the really cool thing now is that these small, low-cost devices can now leverage infinite cloud computing resources. So microcontrollers that cost a couple bucks each can now connect to a AWS server farm that has 100 GPUs behind it. You can do amazing things with this technology without actually including all that compute on the edge. So devices can have edge compute and still be part of an IoT architecture. So that's kind of irrelevant to the inclusion of it being classified as an IoT device, and offering connectivity from anywhere in the world. So the key part of the Internet of Things is, of course, the internet, and allowing different devices to talk to each other, to access services, be that storage or compute, AI, ML, all that kind of goes into it. And one thing I want to highlight is an approved solution for NASA IoT mission and research use cases exists today. This is part of a project I've been working on for the last 3 or 4 years called the IoT platform, and it just went online in January of last year. So the IoT platform is essentially all of the back-end architecture that supports NASA-developed IoT solutions. So this isn't like a way to onboard your Google Home device at work, right? We can't support that. But if you want to develop something that has a NASA use case and can leverage this sort of data exchange architecture, we have that available for you. The primary capability and the purpose of this cloud system is to exchange data between systems and devices. So if you have a mobile application or a HoloLens and you want to get access to a data feed, we support all that good stuff. In addition to just the data exchange, we provide data capture and storage. So if you have a sensor that's collecting information and you want to create a dashboard and do some analytics on that, or maybe even automation, if you have a sensor and then based on that value, you want to control an actuator like a temperature fan that's responding to temperature, you can build those sorts of automations and data capture solutions, and even the dashboards on the services we provide. We're working towards a enterprise data science MLOps solution. So this is going to be Kubeflow. And essentially what that does is it takes a lot of the data science capabilities that are traditionally done on your desktop, moves all that up to the cloud. And for a couple of reasons. One, of course, being you can access much greater GPU compute. You can train models, that you would take forever on your laptop. But it also provides a centralized repository where you can now have all of these models are accessible to researchers. And the final thing is deployment. So when you actually have a model that does something useful, where do you go then? Do you include it in a script and upload it to a server somewhere, VM? So Kubeflow handles all that for you. It gives you a spot to dump your model, deploy it for inference, have that running in real time. So again, our communication is built on this publish subscribe model. It's actually using what's called the MQTT protocol. And what's really cool about that is the data from your sensors goes to an endpoint topic, and anything can connect to that or subscribe to it and get that data feed in real time, which opens up some interesting doors I'll talk about in a sec. We're fully containerized, again, using all open source software. This isn't really this isn't cool for what it is. It's really just an industry standard deployment of an IoT architecture. It's cool for where it is and the authority to operate that we have. We have a free version available via NAMS request if you just want to sign up for it. And we also have paid tiers for if you need more privacy or platform customization. Because we're containerized, we can clone all of our containers, give you your own instance, and you can tweak that to your heart's content. So just to give you some examples of how we're using this today, NASA Smart Centers is the big one. We're importing facility operations data from Johnson Space Center as well as one facility at Langley into our environment, essentially cloning all the existing measurements that we're capturing. To date, I think we've got about 1.5 billion measurements from Johnson Space Center going back to the beginning of 2001. And we really specialize in high volume, high speed data transfer. But another use case that emerged outside of our own group was the UAS telemetry command and control. So this was a effort designed, I can't recall the name of the director now at Langley, but they built an interface to the MAVLink protocol, which is what connects drones to their ground stations. And through this interface, they're essentially piping the data through the IoT platform. And what allows them what that allows them to do is to either visualize it through a web interface, which you see here on the right, or even control drones remotely from remote locations. So you can imagine a scenario where NASA may operate a drone equipped with FLIR infrared cameras, and maybe we're flying that over a wildfire, and we want to hand off control of that to the commander for positioning. And then when it's done, they want to hand it back to NASA to allow them to regain control. So we can support those types of use cases today. So we could build and deploy IoT solutions. That's not really the point of this presentation. But the question is, what else can we do with all this great data that we're collecting? So going on a tangent for a second, improved remote data access is extremely important. When people on the ground have access to good data, they make better decisions, they respond faster. You actually improve safety in the case of a mechanic working on a system, for example, especially when you have multiple operators working on a very large and complex system like we do at NASA. People will know, is there pressure in this pipe before I disconnect it, or is the energy really turned off to the system? Is it in a lockdown state? So this can augment all the existing controls that we have in place today, like lockout, tagout, by just giving you an extra double check to make sure, yeah, this is still safe, showing you what that sensor is seeing in real time. Consolidated knowledge, so access to geographically distributed systems. So when we have pumps in place today, we may have 50 of those pumps across all NASA centers, but within one center, we're only aware of 5 of them. So if we want to do prognostics or look at operational state, or is this bearing vibration really in spec, we can actually go across all the different centers and kind of look at what's going on. If you can imagine that power to have that level of analytics in the hands of a technician, it's extremely useful, extremely beneficial. And the applications really extend beyond facility operations. So whether you're developing something for research, or this is a mission platform, or this is any kind of ground support platform, if you have a need to move data and capture data, that's really kind of what we're all about. And improving the access to that data is of utmost importance. When we look at how data access technologies have evolved, of course, we started with analog gauges and moved to paper chart recorders. And then there was this move to digitize. Once we had digital information, of course, we could consolidate that, have PC-based control rooms that have access to all of the sensors in a facility. And solutions are now moving towards tablets and smartphones. And if we look at the trend, really what we're seeing is this trend towards digital consolidated mobile access. So digitizing the information we have, storing it, consolidating it in one place, and making it available to the people on the ground. But the question we've asked is, what's next? And that's where the HoloLens comes into play. And all of you are probably familiar with this device. It's an augmented reality headset, semi-transparent panels, gesture controls, leave both hands free. And you have capabilities like remote assist. So this is very valuable to our operators on the ground, our facility technicians who need to work on a machine and also have data or also have that video call all in the same place. Versus having a tablet propped up somewhere, or even worse, in their hand while they're trying to do something else. So our lead engineer at our Langley compressor station, Kirk Cole, had this concept of exposing all of this machine data in augmented reality on the HoloLens, so that operators, when they're either walking around to view the machines, they can actually see what those measurements are without running back and forth to the control room to actually look at the screen to see what's going on. So he teamed up with a local university through a Space Act agreement to develop this application for use with the Allen Bradley data systems inside a compressor station. So it was highly specialized. It used some really quirky ways of getting access to data because their system has to be air-gapped for security. But what it did give us was feedback that this was valuable. This is something that the operators could use. We took some really important lessons, such as the need for the HoloLens display to be ballistic rated to be used in this environment, as well as just some other comments and concerns about the device. If you remember the original HoloLens 1, it was very front heavy. It was uncomfortable to wear for more than a few hours. Field of view wasn't great. So we kind of took all that and put it in our back pocket. And that project has kind of been on the shelf. So as we were developing the IoT platform, what we realized was we had all of this operational data consolidated. That was really our goal, is to get all of the data in one place where it's accessible, where you don't have to write a custom API every time we plug in a new system to our infrastructure. So we really wanted to build something as universal and general purpose and reusable as possible. And that's where this application came about. So this is designed for HoloLens 2, and essentially what it does is it connects to our IoT platform and streams the data in front of you in a augmented reality panel. Today we're using QR codes, and the way we have our QR codes implemented is unfortunately they need to be fairly large in size for the HoloLens camera to be able to read them accurately. But we embed in that QR code the IoT endpoint. So when the HoloLens sees a QR code while it's running our application and it sees that IoT endpoint, it knows where to connect and it knows where to position that panel. So if you can imagine a QR code on a pump or on a motor, on a compressor station asset, or even maybe something in space, you can simply look at this device and the headset will establish a live data connection and start streaming information to you kind of in real time through the use of this application. What's really cool about this is if you're building a research application or you're doing something new, or maybe you don't necessarily want the advantages of the IoT platform, but you want a really quick way to get your data into AR because it's useful in a certain physical location where you can't see it. You can now just pipe that data into the IoT platform, fire our app, print out a QR code, and there you go. And now you have access to platform data. So a really easy and convenient way to leverage the HoloLens for data streaming. One other note, I just want to thank all of our student interns. So over the last couple of years, we've had 3 different interns working on this project. They've unfortunately all moved on to very successful careers outside of NASA, but I think this is just something we can all be proud of, and always glad to have intern help with this. So I've got a quick video to show. It's probably not going to play because Google is being funny, but counted for that. This is our, there should be no sound. Don't worry if you can't hear anything. I was wrong, there's sound. So here you see the certificate selection. We use certificates to authenticate to the IoT platform, so everybody needs a special certificate. And here's the QR code. You can see some debugging information, including the IoT endpoint. And it pops up a panel and displays the data, and that's really all there is to it. We got a couple other features kind of baked in, where you can position the panel, resize it, you can pin it to the wall, and that sort of thing. Just really basic stuff that a technician might want to do. And what's actually interesting about this is this intern doing this work and making this video was doing this in Ohio. this sensor that you saw him connecting to was actually in my house in Virginia. So it's really kind of a testament to the ability to access information no matter where you're at. So moving forward, we've got plans for this app going forward to continue to bring on students and make this a more robust and useful application. We use Grafana on the website to do our web analytics. What we want to do is bring the Grafana panels into augmented reality. For one, because they look a lot nicer, you can customize them a lot more. So you see, instead of seeing a humidity measurement, maybe you'd have a gauge. But also you can make more useful visualizations. The other cool thing about Grafana is because it ties into our data store, you can view historical data. So if you want to view the trend of a measurement over time, you'll be able to configure a augmented reality panel to do that as well. Moving forward, we're definitely moving away from QR codes. We found that the QR scanning capability of the HoloLens is less than ideal. It can do it. You just have to get the device extremely close to the QR code in order for it to read it. And this gets worse the more data you try to embed, because as you embed more data in the QR code, the dots get smaller and the headset has a harder time locking on. So moving away from that, we're going to go towards Azure Spatial Anchors. And what this does is essentially lets one user place the panel and register that device in a place in the world. So a pump's speed or its temperature, for example, its bearing vibration. And once one person does that, the next guy to come along with a different HoloLens and that has our application loaded will see that panel placed there and registered. So it'll just be a single activity to go through a facility, register what makes sense, set up your dashboards, and then that's it. You don't need a marker. The HoloLens knows, oh, I'm in the compression station. This is where I'm standing, and that's enabled through this cloud service. And then it'll be able to look up the appropriate IoT endpoints and display that. So we also want to move towards holographic control panels using IoT platform messaging. So the same way you can receive data from the IoT platform, you can also send commands. So you could have a motor that you can adjust the speed on or shut down or do an emergency stop, and allowing all this through gesture controls in that AR environment can be done through the IoT platform. So beyond the HoloLens, there currently is a use case for handheld and tablet and phone-based access, and we do want to make an IoT mobile augmented reality client. So this would be something that if you have an iPhone or Android, you'll be able to download our app and get that same type of visualization, but just on a handheld device. We're also working with the Goddard's Mixed Reality Exploration Toolkit, our Merit project. We would like to integrate live data into models and also stateful representation. So if you can imagine a model such as the Canadarm, and you would have in VR the stateful representation of that robotic arm at any point in time, as well as data and any other telemetry that you wish to send to that platform. And that's all I've got. Open for questions.
Hey, Jeff, do you think that QR code limitation is just because the resolution on the camera, or like, is that likely to get better, you think?
Not with the current hardware. So the resolution issue seems to be based on the dynamic shutter speed of the camera. So as the room is darker, it needs more photons to make a brighter image, which leads to blurriness because it'll slow down that shutter speed. And also as you said, the resolution. So we did have success with like 8x8 inch QR codes, but those are way too big to paste around the facility, realistically.
Right. Yeah, we have like some on the spacesuit side. There's like some inventory use cases right around like inventory management with QR and potentially AR, check in, check out based systems. But that's kind of a shame.
We spent a little bit of time. We didn't buy any hardware, but we did recognize RFID as a potential solution. So there are Bluetooth connectable devices that you can pair the reader with your headset and then go around and scan stuff. That seemed like a pretty good solution. But for us, since we're kind of operating on the ground, I think Azure Spatial Anchors, because it removes all the requirements, is really the best way forward.
Right. Cool.
Any other questions from anyone around the loop? right, if not.
Oh, got a hand up, I think.
Oh, I missed it completely. Yes, Kenji, sorry about that.
That's good. Quick question. Are you looking at using like GPS coordinates for IoT devices tied to the Azure spatial anchors, or are you just using the standard spatial anchor capability for the whole?
This is the standard spatial anchor capability. So the way we understand it is it kind of works without GPS coordinates, in that it's kind of mapping that area using LiDAR, and then as you're in a room, it'll kind of recognize where you're at.
Right.
Yeah, if there's a way we can augment it with GPS, like if we find that's useful for outdoors, we'll definitely explore that. But we haven't looked into that yet. It's a good question.
Yeah.
All right, any other questions around the loop? All right, it doesn't sound like it. All right, thanks for the presentation.
Yeah, no problem. Thank you.
All righty, so next up is Francisco Rivas.